Hello Year 9, it's lesson 5 in the electricity booklet. Let's go and have a look at some electricity basics that you should already know. Electric current, what is it? It is the flow of electrons around a circuit. Current is measured using an ammeter, double M please. The amount of current is measured in amps. If you were to write it down, a value, if you had 3 amps flowing through a circuit, you could write it down as 3 amps, or the units are capital A. If you were to write it down like that in the GCSE, you wouldn't get a mark, okay? It needs to be a capital A. Now the symbol for an ammeter is a circle with a capital A inside it. Now when it comes to series and parallel circuits, there are 5 rules that I would like you to know. Definitely for GCSE you need to know these 5 rules. Now the first one is current that flows in a series circuit. So let's have a look at this video. We are looking at a simple series circuit. It's incomplete at the moment. If I just go through the circuit, we have a gap here. The circuit is incomplete, so the bulb down here does not light up. We've got one battery. The positive end is this yellow end here. The negative end is the dark end. Then we have connecting wires going all the way round through the battery, through the bulb, and then back to the battery. We also have down here a current meter, an ammeter. Normally we put it into the circuit at any point, and I'll be putting this section here into any point in the circuit. Now at the moment the current reading is 0.00 amps because the circuit is incomplete. However, once I link everything up, you can clearly see the flow of electrons represented by the red arrows flowing around in a clockwise direction. And you can see the current reading on the ammeter, just to the right of the bulb, is 0.9 amps. In fact, and this is the first rule, you place the ammeter anywhere in the circuit and you get exactly the same reading, 0.90 amps here, the same up here, the same within the battery, and the same over here. So current in a series circuit remains the same. Remember, current is the flow of negatively charged electrons. They're not used up, they just flow around the circuit. Now, what happens if I were to increase the number of batteries? If I increase the number of batteries from 1 battery to 2 batteries, the current seems to have speeded up. The flow of electrons is greater, and that is because the batteries provide an electrical push. It's called potential difference or voltage, or PD. Now, when we put the ammeter into the circuit, we see that the current has increased to 1.80 amps. However, the rule stays the same. Wherever you look in the circuit, current remains the same. It's only increased because we've increased the number of batteries. So that is rule number 1. Current stays the same anywhere in a simple series circuit. Okay, so we've seen that video. highlighting this again, rule 1, in a series circuit, the current is the same throughout the circuit. Now, what I'd like you to do is construct the following circuit, this one here. How do you do that? You go onto Google, you type into Google PHET circuit, you look at the DC circuit and you go and construct it. And in fact, I've logged on, so I'm going to construct this circuit now, okay? So, battery, here goes the wire, another wire, and then we put in a proper ammeter, like so, another wire. Notice that the current reading is 0 at the moment, the circuit is incomplete, 0.00 amps, put our bulb in, put our wire in. You should be having a go at this yourself. This is not me just having a little bit of fun. You should be doing this as well, constructing your own circuits using the PHET website. It's great, isn't it? It's magic. Oh no, no bulb. What I want is another ammeter. Boom, wire, boom, and there we go. So construct the following circuit. What values does ammeter X and Y provide? Let's put this on, link it up. We're going to get the bulb lighting up, we're going to see the current flowing, and we're going to get readings on the left and the right hand side. Ammeter, bang, there we go. So question 1, what do the values X and Y provide? They are both 1.80 amps. Question 2. So here's question 2 now. Complete the circuit and add in the ammeter readings. So into this here and in there, you write in the values. Whoa. 1.8 amps, and here same thing, 1.8 amps. So question 2 is done. Now 2A, in which direction does conventional current flow? It flowed from the positive end of the battery to the negative end of the battery. So it did a big clockwise loop. So in here, you write down clockwise. B, was the current used up when the electrons flowed through the bulb? No, of course it wasn't. Look at it. The current is not being used up. Okay, it's just flowing from the positive end of the battery to the negative end of the battery. Easy, all day long. So, was current used up when the electrons flowed through the bulb? Big answer, no. Now all we do is we are going to rotate both batteries round in the other direction. Okay, so I'm going to go back to the PHET site here. I'm going to snip it. I'm going to snip that. I'm going to leave those there. Snip that as well, I think. And now we're going to just rotate these round, changing them round into the opposite direction. What do you think is going to happen? Watch the direction that conventional current flows now. It's in the opposite direction, of course. We've gone from the positive round towards the negative, so the conventional current now is flowing anti-clockwise. If you want to add this in, there's the positive, there's the negative. Conventional current flows in this direction. Anti-clockwise. But what can you say about current flowing anywhere in the circuit? It stays the same. Stays the same. Look now, we've still got 1.80 amps here at ammeter X and 1.80 amps here. It's simple. Current stays the same anywhere in the circuit. Ooh, now construct this circuit here. We've got more bulbs. We've got 3 bulbs here. We've got 4 ammeters and 2 batteries. Right, okay, I can do that. Here we go. So let's break things up a bit. Snip it. Bring that down here. Great fun this is. A little bit more wire. Almost there. A little bit more wire. The circuit is now almost complete except at the top here. So what was the current readings in all 4 ammeters? You construct the circuit. I wonder if you get the same answer as me. Remember, all 4 ammeters are going to have the same value. 3, 2, 1, and here we go. Bang. They are all 0.60 amps. So, I'm going to be writing this in now. I'm going to try and write this in now. .6 amps, 0.60 amps, same thing. 0.60 amps here. And this last one, all the way down the bottom, is also going to be 0.60 amps. What was the current reading in all 4 ammeters? 0.6 amps or 0.60 amps. It's the same thing. Notice I'm using the capital A for amps. You might want to write it down like this. It's not a problem if you so wished. These are your 2, well, yeah. all of those are the right answer. So, and there's the answers, yeah, to question 4. Question 5, this top circuit symbol is the one that you might not have seen before, this one here. The arrow suggests that we can vary something. In fact, it is a power pack. We can vary the voltage and therefore the current. In actual fact, that symbol is a variable DC, direct current, power supply. We can increase and decrease the voltage, and therefore we can increase and decrease the current. Okay, so remember, the current flows from positive to negative. Okay, and then on and on and on and on, like so. Now, it's a series circuit. It's got 3 ammeters. Ammeter 1, ammeter 2, ammeter 3, and it's saying here complete the following. We know that A2, this one here, has got this reading here, 0.52 amps. So A1 must be 0.52 big A, and A3 0.52 amps. Easy peasy all day long. And the final thing that we're going to look at today is this: visualizing current in a series circuit. Okay, you, the pupils, could act as electrons in a simple series circuit. When provided with an electrical push or voltage, you would flow around a virtual wire around the inside of your classroom. Your teacher could act as the batteries, providing the electrical push or voltage needed for you, the electrons, to move. And when you all start moving in the same direction, round and round the room, you're flowing like current. If the battery is taken out, so there's no push, you stop. If the battery is put in the other way round and the electrical push or voltage travels in the opposite direction, you start running around the room in the opposite direction. If the push or voltage is bigger, you get to run round quicker and quicker and quicker. But of course, there's a couple of points here. Number 1, what can you say about the number of pupils, you're the electrons, flowing past any one point over a certain amount of time? Well, if 5 of you passed one point in the circuit in like 10 seconds, then another 5 of you will pass another point in the circuit in 5 seconds. And the final point before I end: if we had 30 pupils or electrons at the start of the experiment, you should have at the end 30 pupils or 30 electrons. So the current isn't used up. That will do for today. Well done.